you. Some examples will solve, some tips I'll give. If it is helpful, I'll be the most happiest. The first example today I am solving is a fair die is tossed twice. So how many times it is tossed? Twice. That is very important. That we should note down. So once you note down that it is tossed twice, the total number of outcomes, once you toss it, it is 6. Two times you toss it, 6 into 6, 36. Out of 36, how many are favorable to this event? What is the event now? Second toss has value higher than first toss. Let us see, out of 36, how many have this? So here we see the solution part. Totally when you toss 36 possibilities, we list here like this. So out of these 36 possibilities, second value should be more than the first value. Second value should be more than the first value, like that. In the first row there are 5 possibilities. Second row, 1 2 3 4, second value is more than first, like that. Here 4 possibilities, here 3, here 2, here 1, here no possibilities. So you have to add up all these possibilities. 5 plus 4 plus 3 plus 2 plus 1 amounts to 15. Second throw, that value should be more than the first throw. 2 1 3 1 4 1 5 1 6 1, like that. So total number of possibilities are 36. Favorable are 15. Then what is the possibility? Yes, whatever your thought in the mind is correct. So probability that the value of second toss is greater than the value of the first toss. This probability is a favorable cases divided by total number of outcomes, which is 15 by 36, or if you simplify 5 by 12, we should mark 5 by 12 as the answer. Second one, a fair coin is tossed till head appears for first time. You have to go on tossing a coin. Sometimes head may not appear for long time, but if it appears, you have to stop. Now, see the question very carefully. What is the probability that you need odd number of tosses? The indirect meaning of this is, at the first toss, head may appear, or at the third toss, you want odd number of tosses and it should happen. That is, first time head should happen. First time, third time, fifth time, seventh time, and so on, head should happen. Any number of possibilities. So let us see how we solve this. Here it is. Here it is. See, first time if it happens, it is head is happening first time. If it is not happening first time, first, second time head is not happening, and third time it happens. Or first 4 times it will not happen, fifth time it will happen, or seventh time it will happen, and so on up to infinity. Infinite number of possibilities are there. So wherever or is there, you put plus. Wherever or is there, you put plus. And wherever these dots are there, multiplication are there, you multiply. So what is the answer then? Probability of H is half, probability of tail is also half. So looking to that, this is the possibility. Probability of this is half. This has got 3 probabilities, half into half into half. It has got 5 totally, and so on. So here one number of 2's are half is there, here 3 times half is there, here 5 times half is there. Next will be 7 times half. So I have listed here. This becomes a geometric series whose first term is half, and common difference r is, common ratio r is, suppose I take this upon this, 1 upon 2 cube upon 1 upon 2 becomes 1 by 4. So the answer is a upon 1 minus r, half upon 1 minus r, 1 minus 1 by 4, which is the answer is 2 by 3. Totally you have to mark 2 by 3 for the second question. Third question. It's completely different. In a housing society, half of the families have got one children, single children. Half of the families have got two children. So half one children, half two children. Now close your eyes and pick any one child and ask the question. What is the probability that he has a sibling? That is, he belongs to the family of two children. So once again, I'll tell you the question. In a society, 50% have got only one child, 50% have got two children. Now mix all the children and take one child randomly. Ask the question, what is the probability that he belongs to the family of two children? So let us see how we do it. There is a simple way of doing it. Suppose there are 100 families. 50 families have got single children. 50 family have got two children. So in this way, if you come, every family has got one child, means total number of children are 50 through this way. And here every family have got two children, means total number of children in this way are 100. So this addition gives total number of children in that society, which is 50 plus 100, 150, total number of children. Now how many belong to family with two children? These 100 children belong to family with two children. The question is very clear. What is the probability that a child belongs to family of two children? So this is total possibility. This is favorable cases. Did you guess the answer? Yes. Here is the answer. If a child is selected randomly, what is the probability that he has sibling is favorable cases divided by total number of outcomes. Favorable cases is 100. Total number of children are 150. So that 100 upon 150, or you can simplify this, 2 by 3 you should mark as the answer, which is, instead of 100 you can take any number. 100 is a very helpful number. So that 2 by 3 if I mark, so this is the answer again, 2 by 3. Here we go for the last question, fourth one. Parcels from sender S to sender R pass through sequentially through two post offices. So parcels are sent, first post office, second post office. Now there are two possibilities. Either the parcel is lost or parcel is not lost. Based on that, one question is asked. Each post office has probability of 1 by 5 of losing. That means 4 by 5 of not losing. Given that parcel is lost now, means it has not reached the destiny. What is the probability that it is lost in second post office? Okay. So now only thing you remember, lost possibility 1 by 5, not lost possibility 4 by 5, because both together if you add, it should become 1. Here we see how we solve it. Let us analyze the problem like this. Post office 1. So the two possibilities are lost and not lost. Lost is 1 by 5, not lost is 4 by 5. So that if it is lost, it is stopping here only. If it is not lost, it will come to the second post office. This whole box, let us see that it is second post office. And here again two possibilities. It is again lost or not lost. Lost possibility here also 1 by 5. And not lost possibility here also 4 by 5. Apart from that, now information given is, it is lost, but which post office you don't know. So let us see what is the total probability of losing. What is the possibility of losing in first post office? 4 by 5. Okay, that is 1 by 5, sorry. First post office, if it is lost, possibility is 1 by 5. If it is lost in second post office, it has to reach the second post office. If it has to reach the second post office, first via this lane it has to come. So 4 by 5. And whenever I write and, you have to multiply afterwards. And it has to be lost in the this way. This way I am showing you the way for the second post office to be lost. So it should not be lost in the first post office, but it should be lost in the second post office. That means 4 by 5 into 1 by 5. This should happen and this should happen, and means multiplication, 4 by 5 and 1 by 5 is written for the second post office. So probability of losing in the first post office or means plus probability of losing in second post office, 4 by 5 into 1 by 5, because it is not lost in first post office, lost in second post office. Totally lost possibility is 9 by 25. Okay. Now what they want is, now given that it is lost is given, what is the chance that it is lost in the second post office? Condition probability, intersection of lost and lost in second post office divided by totally probability of lost. Now the numerator is calculated like this. Total lost possibility is first post office and second post office. Totally it is 1 by 5 plus 4 by 25, which is 9 by 25. Out of that, the intersection of lost, this L, and intersection of lost in second post office, this is marked here, you see. This is intersection part. This is intersection part is L intersection lost in second post office is 4 by 25. So this becomes 4 by 25 and totally lost is 9 by 25. Hence it is 25 cancel, 4 by 9. This question is a little involved one. You have to analyze and do it. So just practice that. Once again, we shall mark first the answer, which is answer is here questions, options were not given. So let us mark the answer as whatever the answer we get, which is 4 by 9, which is 4 by 9. So purposely one of the questions I did not give the marking, so that you can mark your own. You can mark your own. One of them is 4 by 9. So 1 by 9, 2 by 9, 5 by 9, and the answer is 4 by 9. You can mark like this. Quickly we shall see the 4 questions, how we did it. A fair coin, a fair dice tossed 2 times. Second toss is higher than first toss. What we did? 5 times plus 4 times, total is 36. Okay, total is 36 because 2 dice you are tossing. In that 5 plus 4 plus 3 plus 2 plus 1, which was 15 by 36, and it became 5 by 12. Okay, if you practice this, you can have that idea of 5, 4, 3, 2, 1, 15 by 36. Next one is a fair coin is tossed and head appears first time. Probability that the number of tosses are required as odd. You should feel that, you should get that. It can appear directly, you can write this. If it appears first time, 1 by 2 possibilities. If it appears third time, 1 by 2, 1 by 2, 1 by 2 possibilities. If it appears fifth time, 1 by 2, 1 by 2, 1 by 2, 1 by 2. Like this, immediately you can write. And the answer is 1 by 2 upon 1 minus 1 by 4, A upon 1 minus R. So it is 2 by 3 is the answer again. You can write. Practicing, you need not go in detail. Similarly here, directly, if there are 100 families, 50 have got only 1 children and 50 have got 2 children, and 2 children family are 100, 100 upon 150, which is 2 by 3 is the answer again. Last one, you have to work out little bit, and working out you can get 4 by 9 is the answer. Please see that you practice these things again and again. If you are used to practice ಮಾಡಿದಾಗೆ ನಿಮಗೆ ಹೆಚ್ಚಿಗೆ ಅದರ ಜೊತೆಗೆ you will get used to it. But through these examples, here CT Mitra JIT KLS wishes you all the best. Take care. Bye bye. Wish you all the best. Bye.
Hello, madam.
Yes, sir.
Any questions from anybody? I'll be able to tell. This is just a sample of what we can do. Still, lot of varieties of questions, shortcut methods, and how to understand the questions to the understand questions to the students. Lot of things we can do, but definitely shortcuts are possible, and backward method is possible in mathematics. Students need not worry that they have lost the touch and all that. With little brushing of fundamentals, definitely it is possible. This is from my side. Thank you once again for everything. But any questions from anybody, please, you are welcome.